Hi, Hi friends. Today we will discuss about lasers. The useful references are displayed in the presentation. Kindly make a note of them. Do you think lasers are helpful for you? Many of you who are viewing this presentation may be of engineering background. Those students who are involved in the first years of engineering may be studying this topic. So you may think whether it is going to be helpful for you or not. Sometimes we will also think whether these topics have anything to do with the real-time world or this it is only useful for our studies. It is not so. Lasers are useful in the real-time world in various domains, various applications. Lasers are being useful. For example, starting from the data storage devices and cutting and welding of materials and metals and the performance of cataract surgery of the eye, which involves low power lasers, and in some defense applications and ranging applications in order to understand the distance between the planetary objects and the earth, it is also useful. And nowadays in optical fiber network, some advancements and improvements are happening because of the laser sources. And that's how we have now reached the level of 5G connectivity. Fifth generation connectivity is achieved because of lasers. Okay, so in whatever field you choose, including the biological applications like biomedical devices, we have lasers doing a great job and helping us. You may be enrolling engineering disciplines in biotechnology or biomedicine or computer science and engineering, triple E, electrical engineering or electronics and communication engineering, chemical engineering, like that. Any field that you are going to pursue tomorrow, you will understand that lasers are going to help you. That's why you are studying these topics in your first year of engineering itself. So in the folder in our YouTube channel, which is free of cost only for the education purpose, we are doing this at free of cost. This in the laser folder, you will go through these topics. That is basic theory of lasers, Einstein's coefficient and their relationships, and what is meant by population inversion and how to achieve that population inversion, along with components of laser medium and modes of laser beam we will discuss. Additionally, construction and working of ruby laser, helium neon laser and semiconductor diode lasers will be covered, and it will be uploaded time to time. If suppose any of these students wish to know about much further of any other laser like Nd:YAG laser, excimer laser or dye lasers, you can post them in the comments and we will be uploading them. So laser is an important invention of the 20th century. Laser, as we all know, is the acronym or the short form of light amplification by stimulated emission of radiation. Laser, though it is said that it is an amplifying device, that is light amplifying device, but still it is a light generating device. Okay, there are several differences between the light radiation that is generated by the laser beam and the normal light which is being emanated from the sources like LED lamps, tube lights, phosphorescent lamps, CFL bulbs and etc. Laser beam has some unique or peculiar characteristics, like the laser beam is highly directional, coherent, monochromatic, and they are highly polarized beams. So Einstein in the year 1916 itself, he had predicted that stimulated emission process is possible. But only in the year 1954 it became practically possible. Okay, theoretically he had predicted that such a thing is feasible. It was predicted in 1916 itself, but for making it happen, scientists have to wait till the year 1954. Later, in 1960, T.H. Mayman and his co-workers, the team of under his supervision, they demonstrated laser successfully. Okay, so when it comes to lasers, three important phenomena have to be understood. Though we say that laser involves stimulated emission only, but still we have to understand the other two phenomena as well. The three phenomena involved are stimulated absorption, spontaneous emission, and stimulated emission. We will see them one by one. What is meant by stimulated absorption? Stimulated means it is being driven by external factor. So here you consider an atom which has two energy levels E1 and E2. So E1 is the lower energy level and E2 is the higher energy level. Normally atoms prefer to stay in the lower energy levels only for maintaining the thermal equilibrium. If suppose there is a chance that the atom acquires some additional energy because of heating the material or because of the radiation incident on the material, the atoms will gain that energy and try to move to the excited levels. So if suppose the atom has to get excited to the state E2, we have to supply an external energy equal to at least the difference in the two energy levels, that is E2 minus E1. We will consider a case wherein we have N1 number of atoms in the lower energy level, N2 number of atoms in the higher energy level. In the initial state, there are no atoms. We will presume that there are no atoms in the excited state. Now, an incident photon, which is coming from outside, is being focused on the atom. So the atom picks up the energy from lower energy levels and they gain this energy and cross the barrier and reach the higher energy level E2. So this process is called as the stimulated absorption process. So the probability of this absorption to occur is dependent on how many number of photons that are incident on the material. Whether only one photon is incident or two photons are incident. For example, if one photon is incident, it can drive one atom to the excited state. If two photons are incident, it will drive two atoms to the excited state. Like that, the photon density is important. How many number of photons are being incident per unit volume of the material helps to change the number of atoms that can be excited or not. Okay, that's why we say here that the probability of transition P12, which means P12 means probability of transition from level 1 to 2, is directly proportional to rho of nu. So rho of nu is the photon density, incident photon density. So to remove the proportionality constant, we are introducing the constant which is called as P12 is equal to B12 into rho of nu. So B12 is the Einstein's coefficient. So friends, remember B stands for stimulated process and 12 corresponds to the movement of atoms from energy level 1 to 2. Okay, so B12 into rho of nu represents the probability. So how many number of atoms from the lower energy level E1 will take part in this process? How to find that? That is very simple. The number of atoms undergoing the process is the product of probability times the number of atoms that are available in the source level multiplied by the time period. So we should know what is the probability, which is nothing but B12 into rho of nu into how many atoms are already available in this level, which is given by N1. Multiply it with the time of exposure of the photons. Okay, so delta T. So here we have NAB is equal to B12 into N1 rho of nu into delta T. Please remember this formula. It is very much helpful for us in the other two cases also. So once the atoms have reached the excited state, now they are going to be in the excited state for some time only. So they cannot be available for all the time. So there is a time which is called as the lifetime for which the atom can stay in that particular state. So after that, the atoms will come back to their ground state with the emission of radiation. So this process, which occurs naturally, is called as spontaneous emission process. The atoms that are in the higher level E2 will come down to the lower energy level E1 by the release of photons. Okay, so this is not driven by external photon, it is a spontaneous process. So here the number of atoms that take part is equal to A21, which is the Einstein's coefficient for spontaneous transition from energy level 2 to 1, multiplied with the N2, which is number of atoms in the energy level E2, and the time, which is given by delta T. Again, the same formula I have used here. Number of atoms undergoing the process is equal to probability into number of atoms in the source. So source here is N2, energy level E2. So N2 is the number of atoms into time period is delta T. Okay. Similarly, what happens here in the process, which is nothing but the Einstein's coefficient for stimulated process. On the other hand, if an external photon which is having an energy equal to E2 minus E1 knocks an atom which is in the excited state E2 before even the lifetime is over. That means still the atom has some more time to stay in energy level E2. Before that, this photon comes and knocks it out. That means it will release 2 photons. So we have amplification. 1 photon giving rise to 2 photons. Okay. So here P21, which is stimulated process, is proportional to rho of nu because it depends on the external photon density rho of nu. That's why we have P21 in stimulated process is equal to B21 times rho of nu. So the number of atoms that are undergoing stimulated process is equal to B21 into rho of nu into N2, which is number of atoms multiplied by the time period. So these 2 photons that are coming out are highly coherent in nature. These 2 photons that are emitted due to one transition will go and knock 2 more photons that are in higher energy level and make them as 4 atoms. So one atom became 1 photon becomes or 1 photon generates 2 photons now. So these 2 photons that are released can knock 2 more atoms in the excited state and generate 2 more photons, so that totally 4 photons will come. So 4 will become 8, 8 will become 16, like that the process will continue. So the light gets amplified and it is a stimulated process leading to the coherent radiation. Okay, with this let me stop. Tomorrow in the next posting you can see the differences between stimulated and spontaneous process, and the relationship between Einstein's coefficient will be displayed. Thank you all.